Hello, welcome back. This is lesson 7 in our unit 4. Today we're going to talk about the final type of mole conversion. Today we're going to talk about going between moles and volume. I personally think this is one of the easiest ones, but I'll leave that up to you to decide on your own. So last video we talked about going between moles and mass. Today, again, is the last of the 3 conversions, mole and volume. So before we jump into conversions, there are some facts that you need to know. So remember, this is Avogadro. He's the dude that said, oh, I want to create a unit called a mole, and I'm going to say just randomly, and honestly through some scientific experiment that we're not going to get into, that 6.022 times 10 to the 23 things is going to be known as a mole. So that's what he did. And what he also had his hypothesis. So Avogadro's hypothesis states that the same volume of gas contains the same number of particles. So it doesn't matter what gas you have, they all contain the same number of particles, provided they're at the same temperature and pressure. So most of the time you'll probably see it at STP. Again, doesn't matter really for us, but they're all the same. So basically what he's saying, all these balloons are the same size, they have the same volume. So he's saying they have the same volume, so they're going to have the same, number of molecules. And so here is what this says again with balloons. If we have a jar, all these jars are going to be the same. We have 2 liters of HE, 2 liters of NE, 2 liters of O2. His theory says all 3 of them have the same number of particles. Okay. So again, we're just going to talk about STP just to mention it, just so you know what it means. Again, it doesn't matter right now. When we get to our unit of gases, then it really does matter because you will need to know what those numbers are. But the values are on the reference table, table A, if you ever do forget. It's just saying that standard temperature is either 0 degrees Celsius or 273 Kelvin, and that pressure is 101.3 kPa or 1 atmosphere. Again, we're going to go into what that means and what those units are later on, just what STP actually means. So, using all of this, at STP, 1 mole, or 6.02 times 10 to the 23 particles, occupies 22.4 liters. So this is what you need to know. 1 mole is 22.4 liters. And so that is our conversion factor that we're going to be using. And so, just like the last few conversion videos, we're going to go 3 questions going from volume to mole, and then 3 questions going from mole to volume. Again, I said these are my favorite because I think they're the easiest. So our given is 11.2 liters. Put your given over 1. You want liters to cancel, and we're going to moles. And we just learned, write this down here, 1 mole equals 22.4 liters. That is our conversion factor, so that needs to get into your head. So 1 mole, 22.4 liters. Liters cancel out, we're left with moles. We set it up correctly. So we are left with 11.2 divided by 22.4, which gives us 0.5 moles. And that is it. Again, very basic dimensional analysis. Number 2, how many moles of argon atoms are present in 15.1 liters of neon gas? So our given, is 15.1 liters. Doesn't matter what gas we're working with. Put your given over 1, and then we want liters to cancel, so it goes on the bottom, moles goes on top. In 1 mole, we know we have 22.4 liters. So again, this highlighted in yellow is that conversion factor you need to just kind of memorize. So just double check ourselves, liters cancel out, we're left with moles. So that's 15.1 divided by 22.4, which gives us 0.674 mole. And that is it. Okay, and the last volume to mole question. How many moles of argon atoms are present in 2.25 liters of xenon gas? Oops. Okay. Argon atoms in argon gas at STP. Okay, so again, there's our given 2.25 liters. Put your given over 1. You want liters to cancel, so goes on the bottom. We are looking for moles. So again, in 1 mole, we have 22.4 liters. That is the conversion that we learned today. Liters cancel out, we're left with moles. We set it up correctly. So that means we get 2.25 divided by 22.4, which gives us 0.100 mole. And that is it. So that's it for the volume to mole conversions. Let's just wrap it up going the opposite way. So here we're going to give you moles and we're going to ask for volume. So number 1 says, what is the volume of 0.25 moles of neon gas at STP? All we care about is the 0.25 moles. So remember, get your given, put your given over 1. Now we want moles to cancel, so it goes on the bottom, and we're looking for liters. And we know that 22.4 liters is 1 mole. Moles cancel out. You're left with 0.25 times 22.4, which gives us 5.6 liters. And that's it. So again, when we're talking about liters, there's no need to use the 6.02 number. There's no need to calculate molar mass. It's just that 22.4 conversion factor. Okay. Number 2, what is the volume of 18.2 moles of argon gas? Again, doesn't matter what gas we're talking about. We care about the 18.2 moles. So 18.2 mole. That's your given. Put it over 1. Again, you want moles to cancel, so moles goes on the bottom. We are looking for liters, and we know that 1 mole is 22.4 liters. Moles cancel out, we're left with liters, and we get 18.2 times 22.4, which gives us 407.68. We're going to round 408 liters. And that is it. Okay. Lastly, what is the volume of 42.1 moles of hydrogen gas? Again, this is the only important part. 42.1 mole. That's your given. Put your given over 1. Then you want moles to cancel. We're looking for liters. And we know that 1 mole is 22.4 liters. Cancel those moles out. We're left with liters. Good job. So we're left with 42.1 times 22.4, which gives us 943 liters. And that is it. Again, I think it's the simplest conversion. If you agree, if you disagree, that is completely up to you. So again, here is your 1 slide recap. So for given a volume, remember you're going to put your volume on the bottom, which is going to be your 22.4 liters and 1 mole. So basically you're dividing by 22.4. That's kind of your shortcut. Going from volume to moles, divide by 22.4. If oppositely you are given moles, you're going to set it up like this, and that shortcut is multiply by 22.4. Again, that is demo, divide into moles, multiply going out of moles. So this wraps it up for the last type of mole conversion. Next video, we'll go through a few of the multi-step mole conversions. So going between, now we're going to add another step. So instead of one-step question, we'll do two-step conversions, things you can handle. So that is it. Have a wonderful day. Bye.